In this lesson, we're working with multiplication. Starting out, we have a whiteboard exchange, so you can get a whiteboard or a piece of scratch paper. Your job is to convert the words into the number in standard form. So I have 3,819, and you're going to write the number that those phrases represent. Here's the first example, 3,819. So you're going to fill in the blanks to answer these questions. 2,470. Write the number in standard form. Are you ready? We're going to check our work in 3, 2, 1. Next question, 4,082. Remember, it doesn't mention hundreds, so what digit can you place in the hundreds position? We're going to check our work in 3, 2, 1. A 0 goes in the hundreds place. 7,007. This time the hundreds and tens are not mentioned. Write your answer. Now let's check our work in 3, 2, 1. We place a 0 in the hundreds and in the tens position. 14,295. The 14,000 now introduces the 10,000s place. Write your answer. And let's check. 3, 2, 1. $25,604. Since 25,000 is more than 10, we need to introduce the 10,000s place. Check your answer in 3, 2, 1. $50,103. Write the number in standard form. Now let's check our work. 3, 2, 1. There is a 0 in the thousand place because we have 50. 50 ends in a 0. And then we do not have a 10 mentioned, so our 0 also shows up in the tens place. Last one of this style, 86,020. And we'll reveal our answer in 3, 2, 1. For this next set of whiteboard exchange questions, you're going to start by rounding to the nearest 1,000. Look to the right. If it's 5 or more, we have to raise it up. 8 is more than 5, so we raise the 1. It turns into a 2, and we place zeros in the 3 place values. Then in the next section, we're going to multiply 2,000 by 3 to figure out our estimation. 2 times 3 is 6. So 2,000 times 3 is 6,000. Again, you're going to start by rounding the blank to the nearest thousand. You have to look to the right to tell you whether it rounds up or if it gets to stay. A 3 is 4 or less, so the 2 gets to stay. And then in the next step, we need 2,000 times 4. 2 times 4 is 8, so 2,000 times 4 is 8,000. Round 3,290 to the nearest thousand. Try this one on your own. Think about our phrase, 5 or more, raise the score, 4 or less, let it rest. We're going to reveal the answer in 3, 2, 1. Now you need 5 times 3,000. 3, 2, 1. Please round 5,901 to the nearest thousand. The 9 falls into the category 5 or more, so we have to raise the score. 6 times 6,000. 3, 2, 1. 6 times 6 is 36. So 6 times 6,000 is 36,000. You are going to round 5,075 to the nearest thousand. 3, 2, 1. Now find your estimation. 3, 2, 1. 5 times 7 is 35. So 5,000 times 7 is 35,000. And then last one of this style, round 6,503 to the nearest thousand. 3, 2, 1. The 5 next to the thousands place rounds it up. Now 8 times 7,000. 3, 2, 1. 8 times 7 is 56. 8 times 7,000 is 56,000. Number 1 says, write the following number in as many ways as you can. Take a few minutes to attempt to write 28,741 in as many ways as you can think. Please pause here to give yourself time to work on problem 1. When you are ready, return to the video to see some other ways that you could write 28,741 that either you thought of or maybe some that you did not. Here are just a few ways that we could break down or decompose 28,741. Here you'll see the number bond. This one is written in what's called expanded form. Here you can see it represented in a place value chart. And then this one is also considered expanded form, but specifically using powers for our place values. What is similar about how 28,741 is decomposed in each of these samples? Each piece is broken down by place value. So here you can see the 20,000. Here there's two 10,000s. Here you see 20,000. And this one also represents 20,000. The ones place is indicated separately on each of these. What do you notice about the expanded form and the expanded form with multiplication? These are both showing the same numbers. This one just has addition, but this one has addition and multiplication in it. Here, it's written out as a number in standard form, added with another number in standard form, but showing each place value separately. In this one, it's showing the digit and then the place value it represents. Would it be the same value if I were to change the order of things? Is this still representing 28,741? Well, yeah, it does. We see the 10,000s place, the thousands, the hundreds, the tens, and the ones, but they're just added in a different order. And we also know that the addition has the property of the commutative property, which means we can change the order around without changing the value of the number. We're going to work with decomposing or breaking apart numbers to multiply using various methods. Here's another way that you could write it in expanded form with multiplication. Rather than using the exponents with the tens, they've shown the place values of 10,000s, thousands, hundreds, tens, and ones. And again, we can change the order, but the value will stay the same. There's still 10,000s, thousands, hundreds, tens, and ones places. Use the read, draw, write process to solve the problem. We use that strategy in lesson 6. Number 2. On a typical day, a grade 5 student takes 24,165 breaths in one day. How many breaths will you and 5 friends take in one day? Now, a typical student takes this many breaths, and we are concerned about you and 5 friends. That means 6 students are involved in this problem. Each student takes 24,165 breaths, and we have 6 students. How many breaths will all 6 students take in one day? Go ahead and work on drawing a model and solving this question. You're going to do this problem on your own. So you'll need to pause the video and attempt to solve this question. There are many methods that will work to solve this question. Choose a strategy that you are familiar with to help you solve this problem. Let's look at some strategies classmates may have used. This one, they broke apart and distributed. So they had 6 students, and each student takes 24,165 breaths. So they broke it apart into each place value, 20,000, 4,000, 165. And all of those pieces need to be multiplied by 6 because we have 6 students. So we have 6 times 20,000 is 120,000. 6 times 4,000 is 24,000. 6 times 100 is 600. 6 times 60 is 360. And 6 times 5 is 30. So they added all of those pieces together and got 144,990 breaths. Another method that you may see, they broke the 24,165 up into their place values. So 20,000, 4,165. And they've created an area model and multiplied each of those by 6. So 20,000 times 6 is 120,000. 4,000 times 6 is 24,000. 100 times 6 is 600. And 60 times 6 is 360. And 5 times 6 is 30. So they took all of those pieces inside of the area model and added them together. And they also got 144,990. Some students may have just jumped straight to the standard algorithm. 24,165 times 6. And you can see 6 times 5 is 30. 6 times 6 is 36, plus 3 more makes 39. 6 times 1 is 6, plus the 3 makes 9. 6 times 4 is 24. And 6 times 2 is 12, plus the 2 makes that 14. The partial product method is the same process, but instead of carrying and adding to it, they do each line separately. So 6 times 5, 6 times 60, because it's in the tens place, 6 times 100, 6 times 4,000, and then 6 times 20,000, and add all of those together. You may also see the tape diagram method, and this one uses repeated addition. So it's me and then the 5 friends. 1, 2, 3, 4, 5. So they've done 24,165 6 separate times. All of those could represent your read and draw part of the process. Then we need to write our sentence for the solution. In one day, the 5 friends and I will take 144,990 breaths. For number 3, multiply, show or explain your work. 4 times as much as 32,157. You just saw several methods to multiply in the last problem. Pick which one makes the most sense to you and try multiplying 32,157 by 4. Let's try the area model. 30,000 times 4, well, 3 times 4 is 12, so 30,000 times 4 is 120,000. Then we need 2,000 times 4. 2,000 times 4 is 8,000. 100 times 4 is 400. 50 times 4 is 200. And 7 times 4 is 28. So now we need to combine all of these blue values to find the total. I have 120,000 plus 8,000 is 128,000. Then I have 400 and 200 makes 628. This is just one of the methods. This is the area model, but you can try the standard algorithm, partial products. You decide. It says, is it helpful to decompose a factor when you multiply? How? We decomposed the 32,000 to help us multiply with simpler values, and then we built it back up. Do you think these methods will work if we multiply with numbers that have more digits? Instead of multiplying by 4, what if we multiplied by 234? Do you think that process would still work? We can still use many of those similar processes, but we would have to adapt them. Would you think any differently when you multiply by a factor with more digits than when you multiply by a one-digit factor? Yeah, there are some differences that you have to think about. Instead of just multiplying by one factor in an area model, you may have more than one row to accommodate for the hundreds, the tens, and the ones place.